Python is dynamically typed. That means this symbol X has no fixed type. It is not declared with any type. This moment it is an integer and the next moment it is a string, right? If you run it, you see that it changes like that. We saw that Python is very high level language. So we have list. We will see list, dictionary, set, tuple. Python is case sensitive. There are basic data types, bool, int, float, str. Although the basic data types are also classes. These are all classes. We will see the high level data structures, like you can have a list of items or you can have a tuple of items. We will see list versus tuple. You can have a dictionary. Dictionary is like a key to value mapping. Set is basically a collection of objects which don't repeat. Boolean, normally they find their place anonymously inside these conditions, a equal to b. A Boolean is operating in the background, and you can have composite conditions. You can say a equal to b and x not equal to y, and you can have them as a variable also. Maybe you are searching in a data structure and you want to keep a flag. You set the flag to false, and if you find it in your search loop, you set the flag to true and break out of the loop. So you can use them programmatically also. For anything, if you want to know the details, then you can use dir. For example, if you want to say what all can I do on a bool, then you can say dir bool. And on the bool, all these things are possible. And you can do the same dir thing for object name also. So now I can do dir on this flag also. That will be more or less the same as the class, but we will see later that objects can have some additional attributes than the class. How to take help? You can say help bool and you get help on the entire bool thing. And now notice what does it say? Help on class bool. And now let me do help on flag. And now it says help on bool object. So already it is telling the point that the contents of the bool object may be different from the content of the bool class. Actually, they are different. So if you want to get help on the whole class, you can do like this, either giving a variable or giving the data type name. If you want to get help on a specific member function, so you can say that help on 2 bytes, and it tells that okay, for 2 bytes it takes these parameters: length, what is the byte order, self basically refers to this object. So essentially, because these int, bool, str, float, they are all classes, that's why you will see this self. You can have composite conditions, you can say and, you can use not, you can use or. Integers, you see this class int, you will see class int, class bool, class str, class float. So they are all classes. What are the operations you can do in an int? The usual things, plus, minus, star, slash. There are 2 kinds of divisions. By default, the division is a floating point division. If you divide, for example, 10 by 20, you get 0.5. But if you want integral division, you can say double slash. That's like discard the fractional part, give me the integer. So that's 0. There is an exponentiation operator, star star. Star star means raised to the power, a raised to the power 3. Because a was 10, so a raised to the power 3 is 1000. Percent the modulo. Often this percent is used to check things even, odd, and other things also. You can have shorthand things. If you want to do a is equal to a plus 5, you can say a plus equal to 5. You don't have plus plus and minus minus in Python. You cannot write a plus plus, a minus minus, doesn't work. But you can use a plus equal to 1. So with all the operators, you can use this shorthand. The syntax is LHS OP equal to RHS. And OP can be anything, plus minus, star, slash, double slash, star star, all that. Floats are decimal things. They are also classes. You can have a exponentiation kind of thing. So if you are saying milliseconds, so maybe you are saying exponentiation minus 3. It is to the base 10. And here maybe you are saying 1.54 into 10 raised to power 5. So you can have that kind of a notation. Otherwise, float is very similar to integers, addition, subtraction, division. Many of the things apply. Again, you can do help float and you can find more. String, they are sequence of characters. They are also a class. When I say sequence of character, there is no char data type in Python. When I say a character, it basically means a string of length 1. And strings can be enclosed in a variety of quotes. You can have this double quote, you can use the single quote. They are the same. Whether you write using double quote or single quote doesn't matter. It matters in the only sense that if, let's say, double quote is coming in the middle of this string, then it is convenient for me to use single quote as the notation. Then it doesn't get prematurely terminated. And if single quotes is coming in the middle, let's say, then it's convenient for me to use double quote. That is the only thing. So the thumb rule is, if you are expecting double quotes in the middle, use single quote, otherwise use the other way. And you can always do other things. You can say that no, even if there is a double quote, I want to use double quote, so you can use a slash. Slash means escape the next character, that the next character loses its special meaning. So this character loses its special meaning, that it was terminating. It's just a ordinary content of the string. There is something called triple quotes. They are very useful. Triple quotes are for multi-line strings. If your string is multiple lines long, you can use triple quotes. And you can use both single quote repeated 3 times or double quote repeated 3 times. So these multi-line strings are very special. They are used for something called doc strings also. Doc strings is for automatically generated documentation. For a function, when you create a function, you can write a doc string and Python will automatically generate the help on it. If you say help that function name, Python will generate some syntax. What all can we do on string? So if you do help str, you can get, what are these underscore, all these things? Actually, there are many of them. One of them called underscore init is the constructor. This underscore add underscore is the overload operator plus. If you are adding 2 strings, this function gets called behind the scene. So let's say you are creating your own class matrix and you want to add 2 matrices. Then in the class, you will implement this function underscore add underscore, and then you can enjoy that notation m1 plus m2. So these are special methods, double underscore methods. In short, they are called dunder, d under, double underscore. More or less the overloaded operators, that how do I do plus, how do I compare two objects like greater than or something. But when we are using something, let's say when we are using str or using bool, we are not interested in these. We are interested in these normal looking functions that on a string I can capitalize and it will return a capitalized version of the string. I can some formatting, I can count occurrences of some character, and there are a lot many. For a string, there are a lot of methods. Is it comprised of alphanumeric? Is it alphabets only? Maybe you're doing some validation on some input. And join and split, they are often used. Refer the man pages. If you want a complete help, you can do something like this, help str. If you want to know just the names of the functions, then the concise thing can be, you can say dir str, and it will just tell you the names of the functions, and then possibly with the name itself you can make out what it does. You can concatenate 2 strings. If there are 2 strings, you can use the plus operator and they will be concatenated. So print hello plus world, it will print hello world. You can repeat a string. You can say, I want to print this word nice 3 times. So into 3, star 3. Star 3 basically means repeated 3 times. Okay. So if I run it, that's what it does. Plus means concatenate and star means repetition. And we will see that this plus and star being concatenation and repetition holds for any sequence. And what is sequence? So sequence is a sequence of elements, if you like. So you can understand string is a sequence of characters. Similarly, list, you can understand it's a sequence of elements. Similarly, we will see tuple. We will meet range. That is also a sequence. So the good news is that this plus and star is holding its meaning for all sequences. So what you learn for strings holds for a list also, for tuple also, for range also to some extent. This you can connect with operator overloading, that for integers plus means add them, for strings it means concatenate them, for list it means concatenate them, for integer star means multiply as a numeric thing, for string means repeat that string, for list it means repeat the list that many number of times. Because string is a sequence kind of thing, you can index into it. You can say that give me the first element, second element, and indexing starts with 0. So you can say give me the first element. So if I say that's h, and let me just print the type of that thing also. So let me say type of s1 0, and you can be convinced that it is not character. There is no data type called char. It is a string only. It's a string of length 1. So you can index things, and indexes can be even negative. You can say that, okay, give me last element of the sequence. So you can say -1. -1 means give me the last one. And if you run that, you get the last one. And there is something called slicing. You have a string and you want a part of it, or you have a list, you want a part of it. So you can have a slice. So slice basically means that a starting index and a ending index. Sometimes you give the step also, we will see. Majorly starting index and ending index. And you can say, give me a slice starting from index 1 till index 3. So index 1 is E and index 3 is this one. But just remember that the range is like this. Mathematically, notation wise, the start is included, but the stop is excluded. So the index 3 is not included. I should get E and L. So you can do that. We will see more of slicing later. I'm just giving a flavor of it right now. And this slicing thing, the way you do on strings, the same way you do on list, the same way you do on tuple. And the key thing to remember is that they all fall in the umbrella category sequence. String is a sequence of characters, list is a sequence of elements, tuple is a sequence of elements. So indexing and slicing works on the same way in all sequences. You can do type conversions. For example, if I typecast to int, is it 1 or something? So true typecasted to int is 1 and false typecasted to int is 0. If you are typecasting an integer to Boolean, so anything non-zero is taken as true, anything 0 is taken as false. That is the notion of truth. If somebody says I have a list L1 equal to 10, 20, 30, is it true or false? It's true. 10, 20, 30 list is true. And if I have a list empty, it is false. So the notion of truth and false is, in object, if it is empty, it is false, or if it is 0, it is false. If it is non-zero or non-empty, it is true. And sometimes you want to convert strings to integers. Maybe you took some input from the user and you want to add it to another integer. So you want to convert it to integer. So you can say int. So normally the basic syntax is that you can say the target data type and some expression. This syntax converts this expression to this target. This target can be my int if I'm converting to int. This target can be bool if I'm converting to bool, and so on. So I might convert a string to an integer. I can convert a integer to a string. Why would I ever want to do that? This example also tries to explain. So basically it is concatenating two strings. Why did I had to do this strnum? Because had I not done it, if I remove it, then I run into trouble, because there is a string, there is a integer. Can I add string plus integer? No. I can add string plus string or integer plus integer. So if I run this, then I will get this error. So that is the reason we were converting that int to the string. So that's type conversion, and sometimes it happens implicitly also. Like if you are doing 15 plus 6.7, so then this 15 is converted to float implicitly before doing the computation. And everything has a type, although we never declare them. But even if you are using literals like 100, that's a literal. There is no variable name. It is a literal. True, 10.1, hello. So they all have types because they are unnamed objects of some type.